mean, we're looking at something that is 6 to 9 miles below the surface of the Earth. It's enormous. We never thought that the magma chamber could be that big.
A recent study into the enigmatic heart of Yellowstone National Park has led to an amazing discovery, which has sent shockwaves throughout the scientific world. A dome-shaped uplift into the very core of the volcano system lurks beneath the peaceful surface of this iconic landscape. But what is happening under the ground other than this discovery that is worrying scientists? Join us as we delve into the intriguing findings, which shed light on a rare occurrence that has the potential to transform our understanding of geological forces lying beneath the Earth's surface. The Yellowstone supervolcano stands as one of the most dynamically active sites on Earth from a geological perspective. This region has witnessed a series of lava flows and minor volcanic outbursts, coupled with 3 of the most colossal and devastating eruptions in the annals of our planet's history. Beneath the vast expanse spanning the states of Wyoming, Montana, and Idaho lies a colossal supervolcano, earning its moniker from its potential to unleash global-scale devastation. This geological behemoth is under constant scrutiny by the United States Geological Survey, tasked with detecting any early indicators of an impending supereruption, an event that has eluded the world for over 640,000 years. In an intriguing revelation, Dr. Robert Smith of the University of Utah achieved a groundbreaking advancement in comprehending the intricacies of this volcanic system. This breakthrough materialized as he discerned a shift in the water levels of Yellowstone Lake. The unveiling of his findings came courtesy of geologist Dr. Robert Christensen, as he shared this revelation within the confines of the Inside USGS documentary on the popular platform YouTube. Dr. Christensen expounded, stating, "Amidst the early phases of fieldwork and the culmination of preliminary geological investigations, a profoundly captivating nugget of additional data emerged. Bob Smith, hailing from the University of Utah, embarked on an endeavor to discern potential signals of ongoing deformations within the bounds of the Yellowstone caldera." He further elucidated, Mr. Smith's perceptive eye discerned a collection of these telltale indicators, notably manifested as fluctuations in the water levels across distinct segments of the sprawling Yellowstone Lake. Given its sheer magnitude, Smith posited that these perturbations might signify an underlying tilting of the lake basin itself. This dynamic, Dr. Christensen continued, manifested in a rise of the water level at one extremity of the lake and a corresponding descent at the opposing terminus. It was during this phase that Dr. Smith astutely deduced that the very caldera beneath Yellowstone Lake was undergoing a process of elevation. With this realization, Dr. Christensen detailed, Smith's curiosity was piqued by the prospect of quantifying this phenomenon through direct measurement techniques. His inquiry delved into the practicality of substantiating this intriguing notion. After concerted efforts, the requisite funding was successfully obtained, paving the way for the execution of the comprehensive survey. The resulting dataset was subsequently placed in the hands of Bob Smith and his team, who skillfully amalgamated it into a series of elevation variations spanning the entire caldera. Their meticulous analysis unveiled a remarkable revelation, a steady ascent of the caldera's elevation by approximately 2/3 of a meter over a span of 50 years. Concomitantly, less pronounced alterations were observed in peripheral areas. Subsequent investigations would underscore the normalcy of this phenomenon within the Yellowstone ecosystem. Researchers discerned a cyclic pattern characterized by episodes of uplift followed by subsequent subsidence. Dr. Christensen elaborated in 2014. The observational data unveiled a distinctive pattern of dome-shaped uplift, a conspicuously substantial elevation change. This finding pointed towards an active magmatic system, a process where magma potentially infiltrates the crust or heats the hydrothermal system, leading to expansion and upward movement of the crust. He continued, subsequent surveys contributed additional insights, showcasing a recurring sequence. Following a decade or so of sustained uplift, a phase of stability emerged, persisting for about a year, only to be succeeded by subsidence. As a result of these cumulative findings, it was conclusively established that the Yellowstone caldera engages in a dynamic rhythm, a pulsating motion akin to breathing, manifesting not solely as a linear upward progression, but rather a complex interplay of upward surges and subsequent descents. Indeed, The overarching deformation pattern of the Yellowstone caldera exhibits characteristics of inflation, yet this phenomenon is far from a continuous progression, punctuated by intermittent phases of deflation. A recent scientific investigation has further introduced the notion that the geological hotspot responsible for the Yellowstone phenomena might currently be undergoing a phase of waning. This conclusion emerged from an in-depth analysis of volcanic deposits dispersed across vast expanses spanning tens of thousands of miles within the region. Thomas Knott, a prominent volcanologist from the University of Leicester, shared in June, "Our inquiry led us to a remarkable revelation. Deposits that were previously attributed to a multitude of smaller eruptions actually represent extensive layers of volcanic material stemming from two previously undisclosed supereruptions that transpired around 9 and 8.7 million years ago. These two colossal eruptions occurred during the Miocene epoch, contributing to a total of 6 supereruptions documented for the region during this temporal span. This implies that on average, the area witnessed such catastrophic volcanic events approximately once every 500,000 years. Comparatively, over the course of the last 3 million years, the Yellowstone hotspot has been the source of only 2 supereruptions. This juxtaposition has led the scientific community to contemplate the notion that the pace of these cataclysmic occurrences might be experiencing a substantial deceleration. These cumulative findings prompt the hypothesis that the frequency of such colossal volcanic events is undergoing a significant reduction. This interpretation, built upon a bedrock of empirical evidence, suggests that the geological dynamics governing the region's supereruptions might be undergoing a notable shift over extended timescales. Approximately 17 million years ago, the mantle hotspot beneath Yellowstone came into existence. This hotspot has fueled the activity of the Yellowstone volcano for over 2 million years, during which a multitude of small earthquakes, volcanic outbursts, and other volcanic phenomena have unfolded. Among these events are the creation of several immense calderas through colossal volcanic eruptions. The historical record reveals 3 significant caldera-forming eruptions. The initial one transpired 2.1 million years ago, expelling such an immense volume of magma that it formed a crater surpassing the dimensions of Rhode Island. The second eruption occurred 1.3 million years ago in Island Park, eastern Idaho, while the third, which shaped the present-day Yellowstone caldera, took place 630,000 years ago. These 3 eruptions etched their mark as some of history's most monumental, measuring 6,000, 700, and 2,500 times larger than the 1980 Mount St. Helens eruptions, respectively. As these colossal eruptions transpire at intervals of 600 to 800,000 years, concerns arise whether Yellowstone is overdue for another profoundly impactful eruption. Were the Yellowstone supervolcano to erupt in the present day, the precise scope of the ensuing devastation is an intricate puzzle to predict. The likeliest scenario would entail the flow of lava. In Yellowstone's history, 90% of eruptions have manifested as non-explosive lava flows, characterized by the relatively gentle pouring of molten rock from the Earth's crust. If the direct outcome materializes, a denotative caldera-forming eruption, the extent of the damage remains a subject of scientific debate, often amplified by media sensationalism. Certain prognostications propose that a staggering volume of magma would be released, capable of filling the Grand Canyon over 11 times. The emission of ash would be so prodigious that it could accumulate several inches deep, even 1,000 miles away from Yellowstone, while flowing lava might extend as far as Calgary to the north and Los Angeles to the south. Some predictions even stretch to the assertion that the ash would obstruct sunlight, provoking a worldwide cooling event. Amidst these varied viewpoints, scientists concur on the catastrophic repercussions. The expanse of North America could be shrouded in ash, with Wyoming and surrounding locales suffering the harshest consequences, leading to the suffocation of numerous plants and animals. Air quality would deteriorate, hindering breathing, and water supplies would become contaminated. Although scientists find consensus in ruling out a mass extinction event, the historical records of the past 3 eruptions provide no evidence of such an occurrence. Jacob Lowenstern, the scientist in charge at the Yellowstone Volcano Observatory, remarked on the possibility of another massive eruption, stating, "If such an event were to transpire today, its repercussions would be catastrophic for the global economy. It would bring about the cessation of most transportation within the U.S., cripple our electrical grid, lead to the loss of millions of livestock, and induce a decade-long or even longer cooling of the planet. Numerous scientists also share the consensus that a substantial explosive eruption is not an imminent concern. The supervolcano is unlikely to erupt for thousands or even tens of thousands of years. Though more than 3 decades of continuous observation, the caldera has maintained a stable condition. Lowenstern highlighted noteworthy instances such as earthquake swarms in 2008 and 2010, along with intriguing cycles of caldera uplift and subsidence where the ground rose by 5 to 10 inches. However, he emphasized that these occurrences fall far short of the type of activity that typically heralds an impending eruption. The absence of indicators leads scientists to hold the view that an eruption in the near future is improbable. Extensive protocols and alert mechanisms are in place to ensure timely notifications and warnings for people in areas immediately affected by a potential eruption. While it's not feasible to avert the eruption, scientists express confidence in their ability to detect eruption precursors weeks, months, or even years before they transpire. Media discourse in recent times has highlighted purported heightened volcanic activity in Yellowstone. However, much of this discussion remains speculative and unsupported by scientific data. Criteria that could potentially indicate an impending significant eruption includes numerous daily earthquakes surpassing a magnitude of 4.5, and substantial land deformations. While the Yellowstone region experiences hundreds of minor earthquakes each year, such geologic activity does not inherently foretell an imminent eruption. The area's renowned geysers, hot springs, and other geological features also do not signal impending danger. Responding to inquiries about potential future eruptions, Lowenstern asserted, "I believe the likelihood of an eruption occurring within the next century or even the next millennium is exceedingly low. The odds are decidedly against it. Our geological research indicates that the present activity in Yellowstone aligns with patterns observed over the past 5 to 10,000 years, a period marked by an absence of volcanic eruptions. No compelling evidence has emerged to suggest impending changes." Fresh research has unveiled a substantial expansion of the magma reservoir beneath the supervolcano located within Yellowstone National Park. The groundbreaking discovery, outlined in a recent publication in Science, has also revealed that the newly identified magma is flowing at shallow depths, similar to the conditions that fueled past volcanic eruptions. The investigative approach employed seismic tomography, a method involving the mapping of seismic wave speed beneath the Yellowstone volcano. By crafting a 3-dimensional representation of seismic waveforms, researchers gauged the volume of molten material while making assumptions about its spatial distribution within the magma reservoir situated beneath Yellowstone's surface. Ross McGuire, an assistant professor at the University of Illinois Urbana-Champaign's Geology Department and the study's author, elucidated, "Our findings strongly suggest that the crustal magma reservoir of Yellowstone contains a more substantial volume of molten material than previously hypothesized." He highlighted that this reservoir encompasses up to 20% molten material situated at shallow depths. In contrast, earlier research posited that the fraction of partial melt ranged from 5 to 15%. This revelation implies a noteworthy reevaluation of the composition and dynamics of Yellowstone's magma reservoir. Rather than being akin to a singular immense chamber of magma, the Yellowstone magma reservoir presents itself as more akin to a snow cone. This analogy illustrates a composite structure comprising both solid and liquid components. Carrie M. Cooper, a professor and chair at the University of California Davis's Earth and Planetary Sciences Department, clarified that the reservoir is far from a homogeneous mass. The newly unearthed insights suggest the presence of relatively small to moderate-sized magma pockets beneath Yellowstone, which have the potential to mobilize and trigger volcanic activity. It's noteworthy that while Yellowstone is often associated with the prospect of catastrophic and explosive eruptions, this research highlights that such events are less frequent than other types of volcanic activity within the park. The newly identified magma pockets, as unveiled by this research, are estimated to be comparable in size to those involved in recent events within Yellowstone's history. These historical instances led to the creation of lava flows that occupied the most recent caldera following a major eruption. In conclusion, the Yellowstone supervolcano's history of colossal eruptions and its potential for significant impact have prompted scientific scrutiny and robust monitoring. While catastrophic scenarios are discussed, scientific consensus leans towards the improbability of an imminent massive eruption. That's all for today. Don't miss out on the latest updates about Yellowstone's seismic activities and other fascinating natural wonders. Hit that subscribe button and ring the notification bell so you never miss a moment of our thrilling exploration. And share this video with your friends and fellow nature enthusiasts to spread the word about Yellowstone's seismic mysteries. Stay tuned. Until next time.